In this video, we'll be learning about symmetrical points and quadrants. So let's start off with this problem. Let P be the point -2, 3. Find the points which are symmetric to P about the x-axis, the y-axis, and origin. So first thing we want to do is we want to identify what is our x values and our y values for point P. So the first value is going to be your x value, and your y value is going to be +3. Now, the next thing we need to do is label point P on the coordinate plane. So for our x is going to be -2. So we're going to go to the left of the origin, which is this middle part right here, and we're going to go to -2. And then we're going to move all the way up to +3. So when we do that, we move up and then we stop at +3, which is going to be right here. So point P is going to be right there. Now, if you want to rotate about the x-axis, there's a formula. So the formula is it's going to be x comma -y. Now, if you notice, our point is in this form of x comma y. So all we need to do to get it from this form to this form is just add a negative sign to our y. So when we do that, the new point is going to be -2 is going to stay the same because for x is just x. And then we have -y. We're trying to turn y to -y. So all we have to do is add a negative sign in front of the y value. Now when we do that, we get the point -2 comma -3. So we go to -2 for our x, and then we move down to -3. So your point is going to be right here. And we can label this, I know I put P right here, but we can label it something different. I can call this point X. So this is point X. Now, what do you do if you want to rotate about the y-axis? What is the formula for that? If you want to rotate about the y-axis, it's going to follow this formula. -x comma y. So if we want to rotate it for the x-axis, we need to add a negative sign in front of -2. But if you notice, -2 already has a negative sign. So what do we do there? So you can write that coordinate as negative, and then in parentheses -2, and then -3. And we can simplify that. Negative times negative is going to give you a positive. So it's going to be +2 and then +3 for the point. So then when we label the point, it's going to be right here. And we'll label this point y. So that's your answer. Now, why does this formula work? Why does the x comma -y work? So what you want to know is you have 4 quadrants. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So your quadrants, the order starts counterclockwise. So the opposite of what a clock would rotate to. Now, what you want to know is the ordered pair for each quadrant. So it's going to be x comma y in the first, -x comma y in the second, -x comma -y in the third, and x comma -y in the fourth. Now, if you notice, let's say you're in the second quadrant, which is where point P is at. It follows that formula, -x comma +y. And then the third one, the quadrant below it, which is where we're trying to rotate it to, has that formula, -x comma -y. So the x value doesn't matter when you're trying to rotate about the x-axis. And it goes for quadrant 1 to 4 as well. If we're trying to rotate from quadrant 1 to 4, we have that formula x comma y. And then the one below it, we have x comma -y. So the x values don't matter. The sign doesn't change if you're rotating or if you're trying to find a point symmetric to the x-axis. So that's why that formula works. Now, how do we find a point symmetric to P about the y-axis? So if you're trying to find a point symmetric to another point across the y-axis, the formula is negative x comma y. So if you notice, for point P, we already have a negative sign in front of x. So what happens? Essentially, what you're doing is you're multiplying a negative sign, or essentially it's negative 1. So you're multiplying negative 1 times negative 2. And when you do that, you get positive 2. So the point, which I'm going to say is point y, that's symmetric to P across the y-axis, is going to be 2, 3. So we label our point right here, and we label it y. Now, why does this work? Because we have those quadrants. Remember, in quadrant 1, it's x comma y, and then the second quadrant, it's negative x comma y. So notice the sign change here. It needs to change sign for the x value to reflect. The y value doesn't matter. The y value remains the same. And for quadrant 3 and 4, it's the same. Negative x comma negative y. Then we have negative, or sorry, not negative. We have positive x comma negative y. So the x needs to change sign. It needs to get multiplied by negative 1. But if you look at the y, it remains the same. So that's why. Now, how do we find a point symmetric to P about the origin? So, whenever we have a point and we want to make it symmetric to the origin, it has to follow this formula. Negative x comma negative y. So we have to multiply each piece of the coordinate, the x and y value, by negative 1. And the reason why is, let's say we have a line splitting it up, because the origin is going to have an x and y value. We want to rotate across it. So whenever we do that, P needs to move to this empty quadrant. And we use the negative x comma negative y formula because if you notice, in the second quadrant, it follows that negative x comma y formula. And then on quadrant 4, it has the positive x comma negative y formula. So the x switches signs and the y switches signs. And it goes the same from quadrant 1 to 3. It's going to be x comma y, and then in quadrant 3, it's going to be negative x, negative y. So both signs change for the x and the y. So that's why we have to change both of the signs for P to get the point symmetric about the origin. Now, let's do the calculation. So we have P, and it's negative 2, 3. So we have to multiply negative 2 by negative 1, which that's going to give us positive 2. And then we have negative 1 times positive 3, which is our y value, which that's going to give us negative 3. So our new point, which we're going to label O, is going to be 2, negative 3. So when we plot that point, we're going to plot it right here, and we're going to label it point O. And if you notice, it's symmetric about the origin. We can split the origin, and it is symmetric about the origin. So for this problem, it says for each point given, identify the quadrant or axis n/on which the point lies and find the point symmetric to the given point about the x-axis, the y-axis, and the origin. So we have our point A. It has the coordinates of negative 3, negative 7. And what we want to do is we want to find a point symmetric about the x-axis. So we want this point to be in this quadrant. So the quadrant that point A is in is quadrant 3. Because quadrant 1 is in the top right, and your quadrants move counterclockwise. So it goes from 1, and then 2, and then you have 3, which is where A lies. So the quadrant for that point is 3. And what we want to do is we want to find where the point symmetric is about the x-axis. So all we need to do is, quadrant 3 has a formula of negative x, negative y. And if you notice, in quadrant 2, it has a formula of negative x, comma, positive y. So what we need to do is we need to change that y value. So our new point, which I'm going to label x is going to be negative 3. So x is going to remain the same because the sign didn't change there. But notice it went from negative y to positive y. So all I'm going to do is just drop the negative sign. So this is going to be our new point. It's going to be negative 3, comma, positive 7. So your point for the x-axis is going to, or your point symmetric to the x-axis is going to be right there. And that's going to be point x. Now let's try to find the point symmetric to A about the y-axis. So we want to find a point that's on the other side of the y-axis. So for quadrant 3, we have that formula negative x, negative y. And we want to take this point and find a point that's symmetric about the y-axis. So that's in quadrant 4. Quadrant 4 has that formula of positive x, comma, negative y. So notice that the y value did not change signs, but the x value did. So that means we have to change the x value sign for point A to get the point symmetric about the y-axis. So I'm going to say point y, it's going to be, notice that we have to change that sign. So it goes from negative to positive. So it's going to be positive 3, and then the y value remains the same, and then negative 7. Let me erase some of this so I can plot my point. So your point about the y-axis for point A is going to be right here. And that's point y. Now, if we want to find a point symmetric to A about the origin, we need to go to the quadrant that's diagonal to the one we're in right now. So basically we want to move to the right and go up, or move to the left and go down, and vice versa. So we want to go from quadrant 3 and move across to quadrant 1. So if we want to do that, we have to change both signs. So we're in the negative x, negative y area, and we want to go to the positive x, positive y area. So what we need to do is drop all our negative signs for our x and y value. So for point O, which is going to be the point for the origin that's symmetric about the origin, it's going to be positive 3, comma, positive 7. So our point is going to be right here. And that's going to be point O. Now, for point B, what quadrant is point B in? It has a positive x value and a negative y value. So that quadrant is going to be in this area. And that quadrant that it's in is quadrant 4. Now, if we're trying to find a point symmetric to B about the x-axis, we want to move across the x-axis, which we're moving up to the x-axis. So that should tell you that your y value needs to change. So when we do that, we're going to get coordinates, and this is going to be point x. We're going to get 1.3, which the x value is going to stay the same, but the y value is going to change the sign. So it's going to be positive 2. So when we plot that point, it's going to be about right here. That's going to be point x. Now, what about the point symmetric to be about the y-axis? So we're trying to move across the y-axis from point B. So when we draw our arrow, it's going to show that we need to move to the left. So that means we need to change our x value because that's a horizontal movement. So for point y, which is going to be the symmetric point to be about the y-axis, we need to change that x value. So it's going to be negative 1.3, comma, negative 2. So when we plot our point, it's going to be about right here. And that's going to be point y. Now, if we want to find a point symmetric to be about the origin, we are going to move in this direction. We're going to move to the top left. So if you notice, this has an x component and a y component. It moves to the left and then up, or up and then left, either order. But you know that you have to change both signs because you're moving to the left and up. So for point O, which is going to be the point symmetric to B about the origin, it's going to have negative 1.3, comma, and then positive 2. So when we plot our point, it's going to be about right here. That's going to be point O. So the first thing we want to do is determine what quadrant C is in. So C is in your first quadrant. Now, how do we find a point symmetric to C about the x-axis? So remember, your x-axis, you want to change the y value. So for point x, which is going to be that point that's symmetric to C about the x-axis, it's going to be pi, comma, negative square root of 10. So we just wanted to change that y value. And when we plot our point, it's going to be about right here. And that's going to be point x. Now for the point that's symmetric to C about the y-axis, we're going to call it point C. We need to change the x value. So it's going to be negative pi, comma, positive square root of 10. So when we plot our point, it's going to be about right here. And that's going to be point y. Now for the point symmetric to C about the origin, we need to change both values. So for point O, which is going to be that point symmetric to C about the origin, it's going to be negative pi, comma, negative square root of 10. So your point that's symmetric to C about the origin is going to be about right here. And that's going to be point O. Now we have to determine our quadrant, but if you notice, D is not in a quadrant. It's not in 1, 2, 3, or 4. Point D is on the y-axis. So remember, it said in the question or the problem statement, it says identify the quadrant or axis n/on which the point lies. So it lies on the y-axis. Now, if we want to find a point symmetric to D about the x-axis, we're going to call this point X. We need to change that y value because we're moving down. So it's going to be 0, which that's going to remain the same, and then 8 is going to turn into negative 8. So your point is going to be right here for point X. So if we want to find a point symmetric to point D about the y-axis, what we need to do is we need to change x values. So we're going to call that point Y, the point symmetric to D about the y-axis. So when we change our y values, notice that 0 doesn't have a sign, so you can't change 0 sign. So it's just going to be 0, 0, 0, so it doesn't have a positive or negative sign. And then we're going to have the y value remain the same, which is 8. So notice that it's going to be the exact same point. So it's going to be point D, and I guess we can label y with D, even though they're the same exact point. Now, if we're trying to find a point symmetric to D about the origin, we're going to call this point O, we need to change both signs. So when we do that, remember 0, we can't change the sign of that, so that remains the same. And then positive 8 turns into negative 8. So if you notice, point O is going to be exactly with point X. So that's your answer. Now for point E, which quadrant is point E in, or which axis is point E on? So point E is on your x-axis. It's not in any quadrant. I mean, the E is, this little symbol right here is in the third quadrant, but the actual point is on the x-axis. So our first step is determining what quadrant or axis point E is on. So point E is not in any particular quadrant. However, it is on the x-axis. Now, a point symmetric to E about the x-axis, we're going to label point X. We need to change the y value. So when we do that, we get negative 5.5, comma, and then we have to change the y value, but it's 0. so it just stays 0. So if you want to find a point symmetric to E about the x-axis, it's going to be the same exact point. So we'll label x with E. Now, what about a point symmetric to E about the y-axis? So whenever we want to find a point symmetric to the y-axis, we need to change the x value. So we'll label the symmetric point y, and we need to change the x value sign. So it's going to go from negative 5.5 to positive 5.5. And then 0 is going to remain the same. So our point y is going to be right there. Now, for point F, which quadrant is point F in? So point F is in your second quadrant. Now, we need to find the point symmetric to F about the x-axis. So that means we have to change the y value. So the symmetric point called x is going to have the coordinates of -8, -4. Remember, we keep the x value the same, but we change the y value whenever we're trying to find a point symmetric to another point about the x-axis. So that point is going to be right here. That's going to be point x. Now, if we're trying to find a point symmetric to F about the y-axis, we need to change the x value. So point y, which is that symmetric point, is going to have coordinates of +8, 4. Remember, we need to just change the x value only and keep the y value the same. So that point is going to be located right here. That's going to be point y. And for our point symmetric to F about the origin, we need to change both values. So for point O, that symmetric point about the origin, it's going to be +8, -4. So we change the sign for the x and the y value. So our point is going to be located right here. And that's going to be point O. So which quadrant is point G in? Point G is in quadrant 4. And we want to find a point symmetric to G about the x-axis. So that means we have to change the y value. So point X, which is the point symmetric to G about the x-axis, is going to have the coordinates of +9.2, 7.8. So all we have to do is change the y value. So our point is going to be located about right here. And that's point X. Now, if we're trying to find a point symmetric to point G about the y-axis, what we need to do is change the x value. So point Y, which is going to be that point symmetric to G about the y-axis, we have -9.2, -7.8. So that point is going to be about right here. That's going to be point Y. And lastly, for the point symmetric to G about the origin, we need to change both values. So point O, which is going to be that point symmetric to point G about the origin, we're going to have -9.2, +7.8. So all we do is change both values for the origin symmetry. So when we plot our point, it's going to be about right about here. Right about here. And this is blocking it, so I'll erase this. So it'll be right here. And that's point O. Now, for point H, which quadrant is this in? So point H is in your first quadrant. And we want to find a point symmetric to H about the x-axis. So what we need to do is change the y value. So for point X, which is that point symmetric to H about the x-axis, we need to change the y value. So 7 is going to remain the same since that's an x value. So it's going to go from +5 to -5. And our point is going to be right here. And that's point X. Now, for the point symmetric to H about the y-axis, we need to change the x value. So point Y, which is that symmetric point, we're going to go from +7 to -7. And then we're going to keep the y value the same. So our point is going to be right here. And that's going to be point Y. And lastly, for the point symmetric to h about the origin, we need to change both values. We need to change both signs. So point O, which is that symmetric point, is going to have a value of -7, comma, -5. We have to change the sign for the x and y value. So when we plot our point, it's going to be right here. And that's going to be point O.